So we just spent some time looking at the three measures of center, which are mean, median, and mode. And what we're going to do in this next video is just do a quick summary of how mean, median, and mode shift location based on what our distribution shape is. And so we spent time in the previous chapter learning about graphing data, and we said that commonly we're going to use a histogram to try and graph our data and then fit a smooth curve to that histogram to approximate the shape of our distribution. Things that we're looking at when we consider a specific distribution is where is its center. That's what we're working on right now. Okay. Is it symmetric or is it skewed? And then how much variation is there? And we'll move on to variation pretty quickly here in the next section. So what I have given us on the graph below here or on the graphs below are three different distribution shapes. So this first one is bell-shaped, right? Bell-shaped, nice and symmetric. And when you have a bell-shaped symmetric distribution, the mean, median, and mode are all typically going to fall right around the same place there, which is right underneath the peak of that distribution. That's going to change once you start getting into skewed distributions rather than symmetric. So the next graph I have here is a right skewed distribution. And in this right skewed distribution, it's looking fairly bell-shaped, but then you have this longer right tail. And what that means is you have some values that fall a little farther from the peak out to the right side. Your mode is always going to be underneath the peak. Remember, these smooth distribution curves are fitted from a histogram, and a histogram's vertical axis represents frequency, right? So the highest bar would have the highest frequency, and by definition, mode is the most frequently occurring value. So the mode would kind of be right here in the center. The median, we're looking for where we have about 50% of the area under the curve to each side. You can tell that wouldn't be right here, right? It wouldn't be right there at the mode. It doesn't look like about 50% of the area under the curve is under each side. So in a right skewed distribution, that median gets pulled a little bit further to the right. And then the mean is usually going to be the farthest of the three measures of center to the right in a right skewed distribution. And that's because any of these extreme values off to the right side, the upper side, are going to pull that mean up towards them. And we saw that happening with outliers. We talked about the fact that the mean is not resistant, so it gets pulled towards those extreme observations, whereas the median is going to tend to not pull as much. If we have a left skewed distribution, we have similar things happening. They're just going the other direction, right? So our mode is still going to be right here under the peak of the distribution. The median is a little bit to the left of that. We want it to look like about half the area under the curve is to either side of that median. And then the mean would get pulled down towards these extreme observations on the low side, right? There aren't any on the high side by definition of it being left skewed, as the further left tail is where you have those observations. And so the mean gets pulled down towards those and is going to be the furthest to the left in a left skewed distribution.